Good morning, everyone, and thank you for joining our webinar today. So today we are going through the webinar, Achieving Net Zero, Advancing Your Embodied Carbon Calculations. And so here we'll be focusing on what the One Click software is and how that can be used. So to start off with, my name is Samuel Boswell. I'm an LCA consultant at Symetri, and I will be your today's speaker. And to run through what our agenda is, we're going to run through the about of Symetri, who we are, and we'll move on to the decarbonisation mission of Symetri. We'll then have a short introduction to what life cycle assessment is, and then this will lead on to how One Click LCA, or an introduction to One Click LCA, and then we'll go through a demonstration of how the One Click LCA software can address this, and finally we'll finish with some questions at the end. So starting off with about us. Symetri, at Symetri, we've continuously expanded to provide better leading-edge solutions and services to more and more markets. We're now 1,000 employees, of which are 600 consultants and 100 developers. This is across 7 different countries in 33 different offices, and there are about 400,000 users daily. So this has since been founded in Sweden in 1989. So we've grown through 23 different acquisitions, but also through organic growth. So we're continuously challenging ourselves and our customers to work smarter, and we're proud of the values that we live by. So this is passion, courage, teamwork, and change. We also have our own Symetri technology unit. And this is where we have our own technology and portfolio of products to support the industry. This is Navigate, Cervelia, and also CQ. And the combination of these core values have supported us in a wide range of services which support organizations worldwide. So our decarbonisation mission, what is it? So Symetri is committed to driving sustainability in the industry through technology and expert consulting offerings. We make a positive impact on the market through a focus on decarbonisation. Our technology solutions and competence help our customers reduce their environmental footprint, meet their sustainability goals, and we leverage our expertise and capabilities to work towards a more sustainable future. And so it's not hard to see, climate change is real. It's having a definitive effect on our planet. We can see this by more extreme weather changes, more extreme temperatures, and also more extreme natural disasters taking place. And so it's important, I think, for all of us to address or make some kind of change within our workflows and how we operate in order to try and counter this and improve the safety of the human race. And when it comes to the construction industry, there's some very important and interesting points to make note of, and in terms of why the construction industry is very important to, or will lead the way in decarbonising the planet and reaching net zero goals. So over the next 40 years, it's estimated that the global building stock will double. And so this is the equivalent of about a New York City being built every month. 50% of all raw material extractions come from the construction industry. So of course, that's going to have a very heavy load on material usage, but also the impact. 40% of solid waste also comes from the construction industry. And a very important one is 39% of all carbon emissions come from the construction industry. And then lastly, 11% of carbon emissions are related to construction's embodied carbon. And while these figures are quite daunting, they're actually, what it shows that it is that it puts us in a position, or construction professionals in a position where we actually have the greatest scope to cause change. Because if, say, for example, you were able to reduce the impact of a building by 50%, well, compared to the average person who may stop driving, become vegan, and start recycling everything that they own, the impact that they might have would be dwarfed by the impact that you could implement by decarbonising your buildings. And so this is really where the construction industry has the greatest power to allow us to reach our net zero goals. And so we challenge people to work smarter for a better future, and we can help towards your net zero carbon goals and a carbon neutral future. So I'll now introduce LCA, or the concept and methodology of life cycle assessment. So what is it? Life cycle assessment is a very standardized process. It's a systematic methodology used to evaluate the environmental impacts of a product, service, or building over its entire lifespan. So you take into account all the stages of that building, product, or service's life, and it will then provide you with what sort of impact it is. So you can imagine it as almost the solution to greenwashing, because it's a scientific method to actually definitively calculate what the actual impact of something is. And so this is really why it's gaining traction, and it's becoming a very important part of the construction industry. One thing to note is that, of course, carbon is the one thing that we talk about most. This is actually only one of the what are called impact categories of a life cycle assessment, and it's named the global warming potential. But there are, in fact, of course, other things that are damaging to the environment. And so a formal LCA will take into account these things. And so this could be acidification, eutrophication, ozone depletion, and so on, amongst other things. So yeah, I'll move on to the next slide. And so this, you may have seen a diagram similar to this before. This is outlining the different life cycle stages of an LCA that's performed. It's, as I mentioned, it's a very standardized process. So, I mean, the most base level ISO standard is ISO 14040 and 14044. This outlines how any LCA for anything really should be done. When you're looking at it in regards to a building, the standard is EN 15978, and then for a product, it's EN 15804. The latter two standards use this framework of life cycle stages that you analyze. So you have the product stage, which is A1 to A3. This is really the material impact. So it's A1 is the extraction of the raw material, transport to manufacturing site, and then the manufacturing processes. You then have the construction stage. So of course, what it takes to actually construct the product or building. A4 being transport to construction site, and then A5 construction itself. You then have the B stages, which is the use. And so this can cover a multitude of things. So maintenance, repair, replacement, but also things like operational energy and operational water and so on. Of course, you then have the end of life stage. So what happens with the products or products within your building at the end of their life? So do they get sent to landfill? Are they incinerated to use as energy, or are they recycled? But also any transport that they might go through. And so this is the C stages, C1 to C4. And then the very last one is the loads beyond the system boundary. So this is stage D, and this is anything that you might gain back from materials that you've recycled, for example. And so it's worth noting that an LCA can be flexible. There's different scopes that you can look at. So just below, you've got the cradle to gate, which is A1 to A3. You also have the cradle to practical completion. This is also called upfront carbon. So that would be A1 to A5. You've got cradle to grave, which is the A stages through to the C stages. And then you've also got cradle to cradle, because this is going the full cycle of the product or service that you're looking at. And if I just click there, so at Symetri, there's two softwares, in fact, that allow you to perform this form of analysis. The first one is Navigate Zero, so part of the Navigate suite. This is for the early stage analysis. It's an integration with Revit, or it's a plugin for Revit, and it allows you to apply materials that have the environmental data to the materials within your and family types within your Revit model. And so you'll be able to get very early estimations as to what sort of impact that your design might have. And then there's also, of course, the One Click software, which is what we're going through today. So this is a much more comprehensive form of software and a tool for analyzing this sort of thing. And it will cover every single possible way that you could do an LCA. So at the earlier stages, a construction stage LCA, a technical design stage LCA, but also a post-completion. And it will also provide you with any of the formal LCAs that need to be done. So whether that's for BREEAM, whether it's for the Greater London Authority, any of the international frameworks, which I'll explain a bit more about later on. And so we had a webinar a few weeks ago for the Navigate Zero software. So if anyone is interested in finding out more about that, a link to the recording here that I think's just been posted in the chat as well. And so you can find some information about that there too. Now I'll do an introduction of the One Click LCA software. So to start off with, it's used across the whole construction industry. So by architects, engineers, construction companies, manufacturers, developers, and also institutions. I mentioned that lifecycle assessment is a flexible tool. So there's a number of different reasons why you would do it, but also ways that you can do it. And so this could be used to compare different material options, allow you to specify a more sustainable material. It will also allow you to gain accreditation for certain green building certifications if there's a requirement to do it for that. But also you can benchmark your project, so you can, over time say, well, this is what the impact of these buildings were. We found various hotspots in that. So what we'll do is in our future projects that we work on, we'll know that in fact we should not go for that option, but we should try and use different materials or different products that would be a more sustainable choice. And so it's a very powerful tool. It's not necessarily just sort of means to an end. It's a decision-making tool. And so LCA, here I will highlight the main reasons for using One Click LCA. So firstly, it transforms the LCAs from what used to be a very difficult and time-consuming process to a much more efficient and accessible process for all professionals in the construction industry. It does this by automating most of the processes and also bringing together all available data into one place. And then on top of this, the data is actually, One Click LCA produces the data where there may be gaps within the industry. So it's really at the forefront of innovating for lifecycle assessments in the construction industry. It offers an extensive knowledge base to guide users through the LCA process. As I said, it's designed to make the process, which was historically more difficult, more time-consuming, as simple and as straightforward as possible. It provides a globally connected platform, including the largest EPD databases in the world, plugins for various tools, and also supporting global compliance standards. And then lastly, it integrates with BIM and various other softwares, which significantly reduces the hassle of data management and interpolating this data into your LCA. So just offers as much efficiency as it possibly can. Oops. The One Click software is used by the 9 of the top 10 architects in the world. It's used by 8 out of the top 10 contractors and manufacturers. It provides users with the ability to produce LCAs in accordance with over 80 different green building certifications and regulations around the world. It has the largest database in the world currently, so it's around 250,000 data points, but we are seeing an exponential growth of this because certainly product LCAs or the production of EPDs is becoming more prolific, which is very good for anyone doing a building LCA because it means there's more data out there. And it's actually commonly is being requested as an industry standard tool. And so to clarify the 3 primary solutions of One Click LCA, the first is, of course, building LCAs. This is really the tool that got going. A similar one to that is for infrastructure LCAs. And then the third one is for product LCAs. And so this would be for manufacturers to produce EPDs of their products. And so for anyone who's not familiar with an EPD, as I mentioned, it's a product LCA. EPD stands for Environmental Product Declaration. And this is the kind of data that you use within your building LCAs and infrastructure LCAs. And so I'll now come on to a live demonstration of the One Click software and run through what it looks like, mostly focusing on the data and then the interface, what the data looks like and how you input that, but then more importantly, what sort of results you get out of it at the end. So I'm now on the homepage of the One Click software. It's a web-based software, so there's nothing particular for you to download. There would be things to download if you're using any of the integrations, such as Revit, but the majority of the work takes place on the cloud here. And so on the project homepage, we've got some banners across the top. So this is for any events that may be taking place, any training courses, or any software updates. Below that, we can search through projects that I may have created in the past, and I can also add a project here. So I can choose from building, product, infrastructure, and so on. Below that, I have some folders to organize my projects into. And then beyond that, I've got some loose projects that I've created in the past. So this is a mixture of infrastructure, building, and product. But what I'll now do is come on to one that I've done before. So I'll select this one here, which I have created earlier. And you can see the name. And so what this has now taken us to is what's called the project homepage. You've got the name of my project here, so the Symetri One Click LCA demo. Below that, I have a drop down for some general information. So this is really the information that you input when you create a project, which is very straightforward. There's not too much information that you need to input. We've got the creation date, so when it was made, who created it, the license type that was used, the building type, and then also the gross floor area and the address. So it's worth noting that the building type that you're working on doesn't really make any difference to how the software works and what the user interface looks like. It's really exactly the same for all building types. And then beyond that, we've got an overview of results, which I'll come back to. But most importantly, we've got the designs that I have within this project. And so how the software works is you create projects, and then within those projects, you create designs. A design could be either different design phases. So as your project develops, you create the different design phases or the changes. It could also be different design options. So in this case, you can see I've got a concrete frame, a steel frame, and a timber frame that I'm comparing. But you could at the same time maybe just focus on one aspect of the building. So if you just wanted to compare or see what the impacts of a certain wall buildup for an exterior wall would look like, then all you simply have to do is input information for that, and it will provide you with the results. So what you're looking at is a table. On the left-hand side, we've got what are called calculation tools. So we have BREEAM, we've got the RICS Whole Life Carbon Assessment version 1, which is also compliant with the Greater London Authority requirements. There is currently, it's not quite a regulation, but it's more of a planning application requirement. That means buildings of a certain size or certain footprint and certain number of stories within London has to have an LCA performed at 3 points, at 3 stages of its REBA plan of work. This is for the Greater London Authority. And like I said, it's a planning application requirement. This was almost done in a way of kind of testing to see how LCAs could be used and whether they were effective, with the idea that over time, hopefully Part Z of the building regulations would be updated, and then life cycle assessments would be much more mandated in all building projects. So it's not unlikely at all that in the next few years, life cycle assessments will be commonplace within the architectural process. The calculation tool below that is the RICS version 2, or the 2nd edition. And so this came out on the 1st of July. It's an update of version 1. It's quite similar. It's just the documentation's gone from a 30-page document to a 300-page document. So it's a little bit more extensive in terms of guidance, but it's one of the best guidances out there in the world, if not the best, for how LCA should be performed. So this is now the standard tool or standard framework that you would use for doing an LCA, a building LCA, or infrastructure LCA in the United Kingdom. Below that, we also have the building circularity tool. So slightly different to LCA, but also goes hand in hand. These are only 4 of the 80 different calculation tools that the One Click LCA software provides. So the majority of them won't necessarily be relevant to you because they may be green building certifications for other countries, but there are other tools such as life cycle costing. There's also a biodiversity net gain tool. And there's a net zero carbon tool. There's tools that specialize for MEP projects, for example. And so there's an abundance of different forms of analysis that you can do with the software. The next column is the units. And then, as I mentioned, these three columns are the different designs that I've created. And so if I wanted to add some data to my RICS version 2 tool, for my concrete frame option 1 baseline design, I simply come to this square here, and you can see we've got view results and then the various different data inputs. And so this covers off building materials, energy consumption, water consumption, and so on. So a broad scope of data that you can input. All of these data inputs would be covering off the various life cycle stages that I showed you in the presentation slides at the start. And so what I'll now do is jump to this page here, which is the building materials of my option 1 baseline. You can see that all of the data inputs that were in the drop-down menu appear across the top. And then below that, we've got a filter, which I'll come back to. We then have a foundation, we then have all the different building elements. So foundations and substructures. You've got vertical structures. So this could be things like external walls, facades. You've also got columns. There's horizontal structures, and it goes all the way through to building technology. So like I said, the software is designed to allow you to do a full building LCA, but if you just wanted to focus on one aspect of the building, then you quite simply just input the information that you want to look at. Say, for example, I want to add something to the external walls. I would come to the subsection here, and if I click this drop down, it will then give me a list of all the different material categories that are within the database. And so you can also see how many data points there are for each of these. I can refine the search by typing in material names, manufacturer names, or also EPD numbers, which will just show you everything that's relevant to that. But in fact, what I can also do is use the filter up here. So say, for example, I want to search by material. I could search for common clay bricks, of which we've got 539 data points. There's the country of origin, and then also the data source. So I've already stated that the One Click database is the biggest in the world at around 250,000 data points, but also it has access to every single EPD database that there is. So almost as if the data's out there, it will be on the database. So it's very easy to find whatever there might be available to you. So with brick selected, now when I click the drop-down menu, it's going to give me a list of all the different brick data points that we have. There's a couple of things to note on here. Is because the project's based in the UK, we get all UK data points filtered to the top. So this is local data. And then there's two types of data that you can work with, either generic data or what we call manufacturer-specific data. Generic data is more of an averaged assumption-based value. It's still perfectly acceptable data to use. So it's in accordance with EN 15804, or it's been produced in accordance with. And in fact, at the beginning of a project, it may be better data to use because you won't know exactly what brick you're going for, but this will give you a good estimation of what the impacts might be. Yeah. Manufacturer-specific data is, of course, a particular product by a particular manufacturer. So, for example, this perforated dense-facing brick by Marshall Bricks and Masonry, and they each have this green question mark by. So if I click on this, it will bring up what's called the data card. And so in here, we have all the general information, all the information about this brick. So some general information, you've got data point background, you've got a description, you've got technical characteristics, so it's dimensional information, mass per unit, but more importantly, you've got the environmental profile. So here we can see what the global warming potential is, which from A1 to A3. So this is the kilograms of CO2 equivalent per unit. And on top of that, we have a performance ranking. So we've taken, or One Click has taken all other similar products, ranked them against each other, so you're able to see where it sits amongst them. So whether it's, on the upper end of being sustainable or whether it's on the lower end. This is very useful if you're trying to optimize or decarbonize your project, because you're able to see what a better product would be for you to improve the sustainability. And then lastly, you can also download the EPD directly from here. And so this is what an EPD looks like. You've got the environmental product declaration. It will state what standards it's in accordance with. And an EPD is a third-party verified document. So it's really as legitimate as the analysis of the impacts of a product can be. They might look slightly different depending on who's produced it, but they'll all contain the same relevant information. So you'll have something like this, which is the system boundaries, the scope. So what life cycle stages have been included in the analysis. And then if I scroll a little bit further on, you'll have a table a bit like this, which shows you what the impacts of each of the impact categories are. And so that's what an EPD is. And this is really what the data looks like. So if I'm happy with the material that I've found, I can just click on it. It will then add it to our project here under the external walls. And we can see we've got this one, which is the lightweight brick system. We input the quantity, and we can select the units for it. And once I click save, it will then automatically update the embodied carbon here. And so if I click on this, you do get a breakdown of where the different impacts are coming from. So transport, site operations, and so on. We have a comment, the building element, according to the RICS classification. I think it's specifically the NRM3 element categories. And so this is in line with the RICS version 2 guidance. You can apply a company classification. So if you have your own way of classifying materials, you can use that. And then the graphs will be able to be reflected in according to these. You have the transport distance, the mode of transport, the service life, how often it's repaired, percentage of waste, end of life process, and then whether the material has been reused. One of the aspects of the RICS version 2 guidance is that there are now uncertainty factors that you can take into account. And so here you can specify whether the technological representativeness of this material used for your LCA or your building is good or not so good. And same with the uncertainty factor. So this just then gives a contingency value at the end of the LCA to say, this is the potential margin of error of my LCA. So this is actually a very useful and quite a clever way of adding an additional level of certainty to an LCA. So all of these values are input by default market assumptions. So at the beginning of a project, of course, you're not going to know exactly where that product's come from, but these are perfectly acceptable values to use. So they are taken from legitimate sources that justify what that value should be. But the idea is that as the project develops, you'll know more specifically where that product's come from. So you can adjust the distances, maybe you can adjust the end of life process and so on. So just before I move on to the results, I've just run through what one individual material looks like. But another thing that One Click LCA has are what are called constructions. And so a construction is simply made up of multiple materials. And so it has this icon here and the little plus symbol. When I click on that, you can see all the materials that it's made up of. And so all the values of the quantities will adjust accordingly to the total size of it. So if I change that to 13, for example, it changes the values there. And at the beginning of a project, you're not going to know every single nut and bolt that goes into your design, but this will kind of fill in that information. So, for example, the amount of mortar that's likely to take place or occur. This will provide the information for that. So it saves a lot of time. And you can, in fact, create and save your own versions of these. So if there are certain details that your organization uses quite consistently, you can create one, save it to your account, and then you can use it in other projects that you work on. And it's very easy to make variations. You would just come over to this side here, click change, and then create a variant or replace. So it gets you going much faster. So that's really everything I would cover in the material. As I mentioned, there are the data input that you can provide information for. You don't have to input information for all of them if you were just looking at the building materials, but this will cover off all of the things that you could. And also the software will highlight the ones that are mandatory if you're trying to do it in accordance with any various standard. But for now, I won't go through all of these just to save a bit of time. But they do work more or less in the same way as a building material. So you choose a energy profile, for example, you specify the kilowatt hours per year, and then it's going to provide you with how much carbon is produced. So now I will move on to the results. And to do this, I'll come back to the project homepage here. And we have about 3 sections on the software where we gain results. The first one is the overview. And so this is, we can select which design we see. So I'm currently on the concrete frame. This middle graph is showing us the embodied carbon by life cycle stage. We also have the embodied carbon by structure. So you have a breakdown of which parts of the structure are producing the most. And then on the left-hand side, One Click has produced, or this is what's called the Carbon Heroes benchmark. So One Click has produced its own form of benchmark. There are a few other ones out there. So you have one for the Greater London Authority, one for LETI, and also one for the REBA Climate Challenge 2030. And I think Neighbours has also produced one too. The way that the One Click benchmark was produced was that projects that had been done within the software in various different countries and of various different building types have been compared against one another. And so therefore the different bands of where that should sit. So currently we're showing the United Kingdom for all building types. And so this one's performing pretty well in the C band, but there's hundreds of different use cases. So you can, if you do have projects from around the world, you can see, say, for example, a school in Finland, what sort of impact that might be. And there's lots of different building types for the United Kingdom as well. And so that's the first set of results. The second set of results would be on the project homepage as well, just here. And these graphs are showing a percentage difference between my 3 designs. So I can choose which designs I show. I'll use all 3 of them. And what I'll do is, in fact, currently it's showing the results for the BREEAM tool. But you can see that there's lots of different metrics for each of them. So BREEAM's taking into account other impact categories. But what I'll do is I'll stick with the RICS Whole Life Carbon Assessment Guidance version 1 because the results are a little bit more simplified. And this first graph is giving us a percentage difference in the total carbon of our design. So, for example, my option 1 here is, well, option 1 and 2 are about the same. We've got 100% for my option 2 and 99% for my option 1. But my option 3 here, which is the timber frame, is unsurprisingly about 25% less embodied carbon in terms of its whole lifespan. The next graph below that is giving us a breakdown of the embodied carbon by life cycle stage. So you can compare what the results for each of those are. And then this one's very useful because it highlights the embodied carbon by building element. So if we look at my option 2 here, the internal finishes are producing about 890 tons of carbon, whereas my option 3, which is the timber design, is about 650. So obviously whatever I've used for the design in my third option for the internal finishes, that's a much better design choice. So maybe that's something that I want to take forward, even if I am working with a steel or concrete frame building. All of these graphs, you can choose which parts you do and don't show. So maybe there's aspects that you don't want to include in the graphic, but all of these graphs can be downloaded as various image files, and also the raw Excel data can be downloaded. And then below that, there's a couple of combined adjustable charts that you can use. So that's the second set of results. The last one would be for a specific design and specific calculation tool. So here, so in fact, if I quickly jump back to project homepage, to access these, we have, say, for example, like I wanted to look at my version 2 of the RICS guidance for option 1. I click the drop down and then view results. So you can view each of the results for these specific ones. But just before I move on to that, there's one point that I wanted to make, which I missed out on earlier, is that while there are many different calculation tools, one of the really useful aspects of the software is that each of these tools more or less works in the same way. So if I knew how to use the RICS Whole Life Carbon tool, or version 2, the data inputs correspond to this one. So you also, again, got building materials, energy consumption, and same with the BREEAM tool as well. And so if you know how to use one, you know how to use all of them. which saves a lot on the learning curve, but it also broadens the scope of what forms of analysis you're capable of doing. And on top of that, it will always tell you what data you need to input, so you always know you're doing exactly the right thing. And then the last point is that you don't actually have to do any extra work if you want to do extra forms of analysis. So say, for example, I start by inputting building materials to my RICS tool. In the building circularity tool, the building materials will also update with all of that data that I've input for the same design. So all of these things work kind of concurrently together. And so saves you lots of time if you're trying to do various different types of analysis. Okay, so the first set of results here, we're on my option 1 baseline for the RICS version 1 tool, also compliant with GLA. Green mark is actually the Singaporean construction green building certification. They took the RICS guidance exactly as is and use it as their own, which is rather interesting. And then so below that, we've got the table. The results here are laid out with the life cycle stages across the top, and then the total on the side here. And on the left-hand side of this table, we've got the building elements according to their RICS classification. And so this is, so the number corresponds to the total kilograms of carbon equivalent for each of these sections. This can be downloaded as an Excel spreadsheet. So if you want to produce your own graphs from that, it's very easy. And in fact, if we also want to download the detailed report, this will compile all of the data that we've input into the software and provide you with an Excel spreadsheet with everything on it as well. And then you can also export all used DPDs, which will then provide you a link with all of the DPDs in. If I scroll a bit further down, you have a plausibility and completeness checker. And so this is the aspect of the software that's running through and detecting if anything's likely or potentially wrong. And so there's thresholds, and it's just checking whether it's within that. So you can see currently we have 0 for the external areas. So it's just saying, is that correct? Were we meant to input information for the external materials? In which case we can validate it and just say, yeah, that's fine. Or maybe go back and adjust the things that we need to. There's also the most contributing materials. This is very useful if you want to improve the design or find a material that would be a more sustainable choice. And so we can see, for example, this reinforced steel bar is producing 136 tons of CO2 equivalent, and that's 6.4% of the project. So I can then show sustainable alternatives, and it will give me a list of other materials with similar properties that would be a more sustainable choice to go with. And so it helps you understand what sort of things you can do to improve the performance of your building. Another feature is the compare data function. And so we can add materials from here to the compare section, but also when you're inputting materials in the material inputs screen, you can add the materials to compare at that stage. And if I could click on this button, it brings up this new section. And so in this, I've got 8 different structural steel profiles. You can see what the total carbon is for each of them. What I can also do is overlay the cost data. And then this provides quite a useful graphic to then provide to clients and stakeholders and say, these are your options. This is what the cost to carbon kind of trade-off might be. Which one would you like to go with? And it provides that easier for that sort of discussion. And the last section here is that we've got all the ways in which the data can be visualized. It will be. So we've got all the various different graphs. You've got the total kilograms of embodied carbon by life cycle stage, also by classification. You've got by resource type, and then also mass by classification too. So you can really see where the hotspots are. So again, internal finishes for this design are very high. So maybe at this point, I duplicate this design, tweak some of the internal finishes, and therefore I iteratively improve the performance of my building. And again, all of these graphs can be downloaded as various image files in Excel spreadsheets, so they can be displayed in different ways, whichever way you might want to. But there's also bubble diagrams, Sankey diagrams, tree maps, and so on. So a broad scope of ways in which you can visualize the data. Just underneath that, we've got all the data sources that we used within this design, and you can download the EPDs directly from here. But this is everything that's been used to calculate the LCA or the impacts. So that covers off pretty much everything for the One Click LCA software. It covers kind of one aspect of it. I think just before I move on, I will quickly show you how things like the building circularity tool differ. So here, for example, the inputs, as I mentioned, are pretty much exactly the same. But if we come on to the results, you'll see that you get a slightly different visualization. So I mentioned before that building circularity really goes hand in hand with life cycle assessment. It's not looking at the whole lifespan of the it's not looking at all the life cycle stages of a building, but what it's looking at mostly is the initial stages and then the end of life stages. And so you get this very unique graph, which shows the materials recovered. And so this is the input material. You get a score based off of anything that's essentially not virgin material, because of course, virgin is not circular because it's being extracted from the ground. And so obviously I've got quite a high level of virgin material used to construct this building. So maybe that's something I want to address. But you get a point or a score for anything that's renewed, recycled, or reused. And then this final score here is just a combination of these three. And then you come around the graph and then you have the output materials. So this is what happens to the materials at the end of the building's lifespan. You get a point for anything that's reused, recycled, downcycled, or used as energy. But of course, anything that's disposed of, that's being sent to landfill, you don't get a score for that because that's what we're trying to avoid. There are multipliers on these. So I think it's a score of 1 by default for reused and recycled. And then the multiplier is 0.5 for downcycled and used as energy, because it's not the best scenario, but it's not the worst. So it's still relevant. And then you'll get a final score here. So the total circularity of your building is quite simply the mean value between these two totals here. And so my current building is scoring about 30% of circularity. And so building circularity is not necessarily as formal as LCA. There's not a formal guidance in terms of how it should be done. It is definitely something that's becoming more and more heavily focused on within the construction industry, because it's certainly got its place. It's very important, and it's a very logical concept on how you can reduce the impact of something, because of course, if you're recycling stuff, then you're not going to be producing the environmental impacts that occur at stages A1 to A3, because you're not extracting anything from the ground. You're not necessarily transporting it to the manufacturing site, and you're not necessarily performing any manufacturing processes. You're just taking it from one place to another to then reuse. And so there's the concept that was produced or put forward by an organization called BAM, B-A-M-B, which is Buildings as Material Banks. And so this idea that buildings over time, or buildings should be considered as storage units for kind of complex and developed products that can be used over and over again. And this is what building circularity tries to achieve. And so you get a breakdown of all the different results here. So this just gives you an example of the different form of analysis that can occur on the One Click software. It's not necessarily just to do with lifecycle assessment, but it covers off many things that go hand in hand. Also, similarly, lifecycle costing, for example. So I've gone through the One Click software. I also mentioned that Navigate Zero fits very well in for the earlier stages. And so to clarify, Navigate Zero empowers everyday designers with tools to inform decision-making and effective lifecycle assessment analysis, whereas One Click LCA supports more of an in-depth lifecycle assessment and robust reporting for the various different means, providing specialized users for core specialized solutions for core users. I hope you found that interesting. And feel free to get in touch if there's anything else you would like to find out more about.